All right, the next question I want to look at from this practice test is number 16. Number 16 seemed to have a few issues on the practice test. So I want to go over this again, trying to hopefully maybe give you a visual and just help make your life a little bit easier. This problem is talking about acceleration. The things that probably confuse kids with acceleration is the units. The units on acceleration are feet per second squared. So a lot of times you'll see something like feet per second, which gets confusing. But I guess what I want to look at right here is just looking at maybe this visual. If I drew a number line and I labeled this number line the acceleration of the car that's given, I would have, in this case, a car going from 88 feet per second squared up to 220 feet per second squared. I know that the acceleration from 88 to 220 took place over a total of 3 seconds. All the question is asking is how much did this car accelerate each 1 second? So if I broke this up into 3 parts for 3 seconds, there'd be part 1 here, part 2 there, part 3 there. All this is asking is how much should it accelerate each one of those seconds. So what I'm going to do is I'm going to figure out the increase from 88 to 220. That would be easiest done by taking 220 minus 88. So we can see that in 3 seconds total, we accelerated 132 feet per second squared. So our acceleration in those 3 seconds is 132. Obviously, we're trying to figure out how much it accelerated in just 1 second interval. So we're going to divide this by 3 pieces because there's 3 of those segments in this 3 second interval. And 132 divided by 3 is 44. So in 1 second, we accelerated 44 feet per second. H would be your answer. Next question I want to look at here is number 19. This was the next low scoring question on our practice test. We can take a look at reviewing scientific notation. In this case, both these very large numbers could be written in scientific notation. Remember, to write a number in scientific notation, we move the decimal until our leading number is between 1 and 10, not equal to 10. So if we count how many spots we move here, we move 1, 2, 3, 4, 5, 6, 7, 8 spots. So this is going to be 6.7 times 10 to the 8th. Plus, same thing here, we're going to move 3, 6, 7, 8 spots if we count them. So here we're going to have 7.0 times 10 to the 8th. Now, what I want you to recognize here is that this is multiplication, and this is multiplication. We're adding these together. Oftentimes on the ACT or in math in general, when we forget rules about scientific notation specifically, I like to come back to another numerical example. If I take 2x, which is 2 times x, kind of like 6.7 times 10 to the 8th, and I add it to another 3x, which is maybe like 7 times 10 to the 8th. Notice again here we're multiplying here and here, as well as here and here. If I asked you to do this, everybody could tell me that this was equal to 5x. Well, how did we come up with 5x? In order to come up with this 5, we just added this value and this value, or in this case, the 2 and the 3. So all we're going to do here in this problem is we're going to add 6.7 and 7. When we add 6.7 and 7, we end up with 13.7. Well, notice when we did this example, we had 2x and 3x. We don't actually add the x's together. We just add the coefficients, and that x stayed. So similarly, this part, 10 to the 8th, is going to stay. So we have 13.7 plus 10 to the 8th power. Now, there is one issue here. The first thing you'll notice is that this is not even an option over here for A, B, C, D, or E. We have to remember that scientific notation has to be between 1 and 10, so we're going to have to move this decimal place right there to get 1.37 times, in this case, if this number becomes smaller, we should try to make this number larger. So we're going to make this 10 to the 9th power. So again, if this decreases, your exponent should increase. So our answer here is 1.37 times 10 to the 9th power. I just noticed that right here. This should be multiplication. 1.37 times 10 to the 9th d. All right, the last question I'm going to look at in this video segment is number 20. Also one that we struggled with as a whole on our first practice test during ACT prep. Hopefully by going over some of these, we can improve our scores in the next one and continue to prepare for the test this spring. So in this case, we have a trapezoid ABCD, as you can see. AB is parallel to DC. The first thing I'm going to do here is I'm going to take and extend the lines to show this. So here we have AB, which is this line segment, is parallel to this line segment, CD. Even if we wanted to, we could use notation to show that they're parallel by putting arrows like that. The measures of the interior angles are distinct, and the measure of angle D is x degrees. What is the degree measure of angle A in terms of x? What we're looking at here is we're looking at a set of parallel lines. We could look at side AD as the transversal. A lot of what we did in geometry talked about parallel lines and transversals. You probably remember things like alternate interior, alternate exterior angles, corresponding angles. And if you have parallel lines like we do here, the two blue lines, A, B, and DC, those sets of angles, special sets of angles, are equal. In this case, we're looking at comparing angle A, which is this one right here, and the given angle X, which is angle D right here. These two angles have a special name. These two angles are called same side interior. They're both on the interior of our parallel lines, and they're on the same side of this transversal. So we're on the inside and on the same side of the transversal. In this case, the special rule to remember here about same side interior angles is that they're supplementary, or that they add to 180 degrees. So these same side interior angles that we're talking about, angle A and angle D, have to add up to 180. So we know that those two equal 180. If this is x, the remainder here would have to be 180 minus x. So angle A plus x equals 180. And it's asking us to find angle A, so we could subtract x from both sides. And we would have angle A is equal to 180 minus x. And that is f. Just to review quickly a little bit more, if I have parallel lines and a transversal, we have special pairs. This angle right here would be corresponding. Those two would be corresponding. And I'm just going to put that those green dots would be congruent. I could use this red dot here and this red dot here to show alternate exterior. Alternate exterior angles are also congruent. I could use a black dot here and here. Those would be what we call same side interior, and those are also congruent. The example we just looked at on the last one dealt with an interior angle here and here, and those are both on the same side of these transversals. So they're on the same side, or inside, I should say, and on the same side of this transversal. So those two right here have to add up to 180. Similarly, these two inside here would add up to 180. So hopefully that's just kind of a quick reminder about parallel lines and transversals that will also help you.